What we're going to do now is finish up our section C.4. The only thing we have to really talk about is how to add, subtract, and multiply and divide polynomials. The only one that's going to take us any work at all is the division. The adding and subtracting are just like combining like terms, which you have been doing for a long time. The multiplication is distribution, which you have been doing for a long time. The division, we're going to refresh your memory on how to divide polynomials. So that's the one where we spend most of our time the last few minutes of class. Okay. So let's do this thing and finish up our review. In case you didn't know, we can add, subtract, multiply, and divide polynomials just like we can add, subtract, multiply, and divide numbers. It's possible. We can put them together, we can subtract them, we can multiply them, or divide them. So we're going to talk a little bit about polynomials today. Also, that word polynomial, that's weird to a lot of people. Like, what's a polynomial? What's a polynomial? There's two parts to that. The nomial part means terms. The poly part means many or several. So what a polynomial is a mathematical expression with several terms. Well, it could be more than one term, they count as polynomials, but usually two or more terms. Those terms, we talk about terms in here. Terms are things that are separated by pluses and minuses. So we're just going to be adding these many terms together if we can. Let's take a look at some adding polynomials. Typically, when you see these problems, you're going to have two sets of large parentheses saying this is our first polynomial plus our second polynomial. That's really what they're doing, is separating those for you. Saying this came from somewhere, this other one came from somewhere, and we want to add them together. So there we go. A couple things right off the bat. Can you tell me how many terms does our first polynomial have?
3.
Good. How about our second polynomial?
3.
So each one of these little parts does not count as a term. The terms are only those things which are separated by pluses and minuses. So we have 1, remember that's a negative, 1, 2, 3 terms, 1, 2, we got 3 terms in each case. Now, we also see these parentheses. We need to find a way to eliminate those parentheses so we can go on and combine our like terms on this problem. The only thing you have to look out for is if you have to distribute anything on these parentheses. So if there are numbers out front, sure, they need to distribute. If there were negatives or a minus sign, you'd have to distribute that. Does anything have to distribute in this particular problem? No, there's nothing out here. There's maybe a 1, you consider it a 1, but nothing in this parenthesis is going to change. Also, this says a plus sign. This is kind of like having a plus 1. If you distribute positive 1, are any of these signs going to change? So when you're adding polynomials, really nothing changes. Those parentheses are just grouping for you. So we can say, oh, nothing distributes. This is the same thing as if I were to write it without the parentheses. The plus is still going to be there. I'm going to have the 3y squared minus 4y minus 10. Nothing to distribute, no minus, nothing's going to change here. You still with me? What now? Yeah, that's it. If you know how to combine like terms, you're done. So basically, adding polynomials is eliminating parentheses and combining like terms. What are my like terms here, by the way? Okay. So we're going to go through it. How I like to do it, I like to circle the term with the sign because that goes with it. And then we use addition rule to combine those terms. So we have a negative y squared. Of course, that means the negative 1y squared. We've got the 3y squared. If we put those together, how much do we have?
2y.
Perfect. So we write that. Should be in order of descending exponent. We're going to cross these out as we go, making sure we don't miss any. Then we look for another couple like terms if there already are there any more like terms.
6y.
6y and what else?
Negative 4y.
Good. Goes with the sign. If we combine those 6y, negative 4y, we're going to get
Positive 2y.
So we put the plus because it's positive, and then 2y. Lastly, any numbers are also like terms. So we have our 1, we have our negative 10. When we combine those using the addition rule here, that's what we're using, we're going to get minus 9. Do we have any more like terms?
No.
No, we're good to go. This is it. It's in order how we like it. It goes y squared, then y, then the constant. That's in our standard form, and that's as far as we go. So does anything change on this if we say we no longer want to add polynomials, we want to subtract polynomials? Let's see. How many terms in the first polynomial?
1.
Good. And the second?
3.
Good. The question is this. Can I do the exact same thing with this problem as I did with this problem? Which means, can I just drop the parentheses and go for it in this particular case?
No.
Okay, good. That's the right answer. That's great. How about the first one? Do I change any of these things?
No.
Any signs over here?
No.
Well, this is exactly the same as this part of it, because there's no number up front, there's no negative or anything up front. I'm not going to distribute or change anything. However, what happens is over here. This is the big deal. And in fact, we saw this on some of those equations you have on your homework, where you had to put those parentheses. You remember that? The negative actually distributed. That's what we have to do here. You've pretty much done this, included in those equations. We just have to keep cognizant of the fact that this minus is really like you're saying a negative 1, and that's going to distribute and change every sign in our second parentheses. So while this doesn't change at all, this negative will distribute. And basically all we're doing is we're going to be changing these signs. So what's the first thing I need to write here?
Negative 7.
And then what after that?
Positive 2b.
And lastly?
Negative 1.
That's it. Then we go through the same process we just finished, combine some like terms. So the only difference is, look at the second parentheses here. If you have a minus, you need to distribute it. If you don't, then don't worry about it, just drop the parentheses. So let's combine some like terms. We're going to do it kind of quickly since we just practiced that. We've got our 5x to the 4th. We've got our negative 7x to the 4th. What's that going to give us?
Negative 2x2.
So we have that one. Are there any other like terms with the negative 6x squared? So we're going to go down the line, but if there's not like terms, we're just going to write it right after that. Then we look for any z's. I've got a z here. I have a 2z over there. How many z's does that make for us? So we put plus 3z. And lastly, we have a plus 1. We have a minus 1. Numbers are like terms. How much does that give us? So we're going to, as far as we can go in this problem. How many people feel okay with adding and subtracting polynomials? We'll start the multiplication. We'll see if we can get through it. If not, we'll just start it next time. Just want to show you what that looks like. So when we have something like 4x minus 1, like that. The question all the time is, how can you get rid of parentheses? How can we, in this case, because we are multiplying between those parentheses, how can we get rid of those parentheses?
Distribute.
Good. Do the what now?
Distribute 4x minus 1 to that other part.
Perfect. So we will distribute. You have something that will distribute this, right? It's not precisely FOIL, is it? It's foil. This is kind of like, well, FOIL, because you get. The thing about it is, the idea of FOIL is every term in the first polynomial gets multiplied by every term in the second polynomial. That's really the idea. We use FOIL because it's kind of a nice acronym. We can go off of that. But here we say, okay, as long as you're taking 4x times all 3 of these terms, and this -1 including the sign times all three of these terms, and then combine like terms, that's going to do it for us. We'll start this next time, okay? Okay, so if you remember from last time, we were working on that problem. We're trying to multiply some polynomials we've already added, and we've subtracted them. So if you look at that, we said that this is not quite FOIL, but it is distribution. Oh, and what the distribution means is we're just going to try to take every term in our first polynomial, multiply by every term in our second polynomial, then if there's some like terms, we'll combine them. Also, I don't know if I mentioned this to you or not, there's an easy way to see how many terms you're going to end up with before you combine like terms. And here's how it works. How many terms are in this first polynomial? How many are in the... What's 2 times 3?
6.
We're going to get 6 terms before we combine like terms. And that'll kind of a double check to see if you have this thing right. So, if you're paying attention out there, what's the first thing I need to do with this problem? What needs to get multiplied? Okay, great. Just be careful that when we're distributing, we're getting the correct exponent, we're doing all that stuff right. So when we do 4x times x squared, we're going to get what?
4x cubed.
Perfect, yeah, exactly right. And then we'll keep going. We're going to do our 4x times our negative, or we're going to consider it to be a negative 3x. Those signs take care of themselves. We're going to get how much?
Minus 12x squared.
Okay. Yeah, I'm glad you got the x squared part of that too, because we do have those 2 x's being multiplied together. And lastly, we're going to take our 4x times our, we're going to consider that to be a negative 2, and we're going to get how much there? All right, so we'll put a minus 8 with the x. Now what?
Minus x squared.
Okay, how are you getting that?
-1.
Good, so we've accomplished multiplying the 4x times all 3 of those terms. Now we'll do that -1. We do have to take that sign with it, so that we're going to consider it like a -1. The reason why we do that is because we could write that plus -1 and distribute it that way. So I guess we're cheating a little bit, but it's not too bad because it's going to come out right. So we do have the negative x squared. Everybody, what's the next thing I'm going to get?
Plus 3x.
Good. Did you all see the plus?
Mm-hmm.
Right.
Plus 2x. Or plus 2.
Yeah, plus 2. So we get those last ones. And sure enough, we have 1, 2, 3, 4, 5. We have our 6 terms. We know at least we've got the appropriate amount of terms. Hopefully we've done this correctly. And the last step is, let's just see if we can combine some like terms, and that'll wrap up our problem for us. Do we have any like terms to combine?
Mm-hmm.
Okay, tell me what they are.
Negative 12x and negative x squared.
Okay, so this one we don't really have any. We're just going to rewrite that. And then, yeah, sure enough, you're right. Negative 12x squared and the negative x squared, that gives us...
Negative 13x squared.
Perfect. We'll keep on going. We have a negative 8x, and I see a 3x when we combine those.
Negative 5x.
And lastly, we have this plus 2 all by itself out there. We haven't missed anything. We've crossed everything out. It's in the appropriate order. We like having this in descending exponents. So a cube, a square, x to the first, and then a number. That's really how we like to write that. That's like a standard form thing for polynomials. How many people feel okay with this multiplication? Okay, let's look at one more multiplication problem and go on to division. That'll take us a little bit more time because I'm guessing you haven't practiced division of polynomials in quite a while. So I'll kind of review that with you. Okay, the question I have for you, is this going to be 25x squared minus 4, or 25x squared plus 4, or something different from those two things? My question is, can you just square this one and square that one? Does that work?
No.
What does this actually mean to do?
Multiply it twice, right?
Okay, so that square says, yeah, we do have a multiplication problem here, but what it really is, it's not just the 5x times a 5x, it's the 5x minus 2 times an entire other 5x minus 2. That's really what we get there. And so you see, if we just square this and square this, we're going to miss out on a real important middle term here, and that would be a problem for us. Why don't you go ahead on your own, distribute this. This one you can use FOIL because we have a 2 by 2, and see what you have out of that, okay? By the way, is there any more homework that needs to be turned in? We can get that to you. Okay, so we are distributing, here the FOIL does work just fine. We're going to get we are going to get the 25x squared. That part would be the same as if you just squared this one. The important part though is right in the middle when we do this. We're going to get a minus 10x and another minus 10x. That wouldn't show up if you just squared the first one and squared the second term. That wouldn't happen. And then we will get a plus 4 at the end. Did you get all 4 of those terms?
Yes.
All right. And so we're going to get the 25x squared. We'll get minus 20x and plus 4. That's as good as we can do. We can't combine that anymore. Do you feel okay about the multiplication idea then? Really just distribution, however many terms you have in the first polynomial times however many we have in the second. That's it. Just combine your like terms after that. Now, the last thing we have to cover is we've done addition, we've done subtraction, we now have multiplication. We're going to look at how in the world you divide polynomials. So we're dividing polynomials here. In chapter 7, we're going to learn how to simplify with division using some fractions. That's pretty much what chapter 7 is about, is incorporating polynomials and fractions together. That's the idea. For right now, though, we really only have one way to accomplish this, and that's through long division of polynomials. By a show of hands, how many people have seen long division of polynomials? Okay, how many people have completely forgotten or have never heard of that before? Okay, that's fine. Have you heard of synthetic division? Okay, you can also do that. You can't do it with this particular one because there's a number right here. But if there wasn't, if this coefficient was a 1, you could do synthetic division. It'd be pretty easy. I'm not going to show you that here. I'm just going to go with long division of polynomials just so you get that concept again. Here's how long division works. You set it up just like you would a normal problem. So as if we were doing a problem just like that. We set up the same way. So we do have a division symbol just like this one. What do you suppose is going to go on the inside of our division symbol?
The 5x squared minus 14 x minus.
And on the outside, we're going to have, well, the second polynomial, what we're dividing by. Yeah, that's our divisor. So we have that out front. Now here's the idea. In this problem over here, what we would do is we'd say, okay, how many times does 5 go into, what would we look for here?
X. Oh.
In this
31.
one. Yeah, we check for the 3, right? But that doesn't count, that doesn't happen. So we go for the next 2, we go 31. We go, oh, okay, 5 goes into that 6 times without going over. And so we put the 6 up top, we multiply, we put the 30 right here, and then we'd subtract and get a 1, and then we would bring down the 2. This is not a surprise for anybody, right? Okay, good. That's a good thing. It's something similar, not exactly the same because we have polynomials. Something similar happens here. Here's what we do. We do check to see how many times, not the 5x plus 1, we really just care about the 5x goes into the first term. And here's how you do that. If you're not too good at dividing, remember we are dividing, this is division. Do it off to the side. What I want you to do, write this first term and divide it by this first term. 5x squared divided by 5x. This first term divided by this first term. Whatever you get here is going to go right there. Are you with me on this? Yes. You're dividing, you're just doing it term by term. And this is going to work out for us. So when we divide here, well, you see the 5's are gone. You've done this stuff before, right? So I'm not going to walk you through that. You've done this. The x is gone, and the x squared is gone. They simplify out. They create 1. So what are we left with out of this whole thing?
X.
Nudge it if you're still okay with that. X is going to go here. it's kind of weird to think of, but you go, oh, how many times does 5x go into 5x squared? It goes in x times. Isn't that strange? That's interesting. But that happens. I mean, we're dividing this term by that term. Now, we're at this step right now. The next step was to multiply, right? Multiply the 6 times 5. You're going to do the same thing here. Can I erase this? You can do the same thing here, but watch. When you multiply, do you see that it is a distribution problem?
Yes.
Which is why you have to cover multiplication before you cover division. So we go, okay, x is going to get multiplied 5x squared. If you've done this right, these will be exactly the same every time. They have to be, otherwise this process is not going to work. So these are going to be the same. And then you're going to have plus x. So far, so good? Okay. And then what do? Over there we subtracted, right? We multiplied and then we subtracted. We're going to do the same thing here. This is just long division. You're just now doing polynomials. So we're going to subtract. Here's the key. Okay, watch carefully here. This is where people make a mistake. It's not really doing this, finding this one. That's fairly easy. We're just taking this term divided by this one. It's certainly not distribution. Everybody can get that one right. It's this part. Here's the deal. Do you notice how right here we're taking this polynomial and we're subtracting this polynomial? Do you see that? We're not just subtracting this one and adding this. What we're really doing, if you think about it, we're subtracting this whole thing. Do you see me? What's that going to do? Remember subtracting polynomials? What's that going to do to that sign? That's going to change. Are you with me on this? Okay, so because we're subtracting, when you remove the parentheses, this sign is going to change. I'm going to write it in purple so you see I'm changing it, okay? Are you still okay with that? So this is going to distribute, make this one a negative. So when you ask later on your notes, Mr. Leonard, how did this change from a plus x to a minus x? It's because we're subtracting, and that minus must distribute. If you're still lost on this, you're at home, you're like, how? What did he do? Watch this part over. Okay? That's why that sign's changing. It's online. Have you been watching them online, by the way? It's kind of fun. You see me all over again. I love that fact. Just kidding. Okay, so now we're here. We've gone ahead, we've distributed. That's the main point for long division is people forget that, and then it doesn't work out, and they go, long division doesn't work. This sucks. It does work. Just remember to change that second sign. Now we're ready to subtract like we do in our regular division problem on the right-hand side. So when we subtract, notice that we've changed this one. We can just consider that to be a negative right there. We're just combining like terms now. Because you've changed that sign, you're just combining like terms vertically. Are you with me on this? So combine like terms. What's 5x squared and a negative 5x squared? Gone. What's negative 14x and negative x? Perfect. That's exactly right. Otherwise, you know what you're going to get if you don't distribute that? You're going to get negative 13x. And that's not going to work with this problem. It doesn't happen. Okay. What do you do after you subtract on this side? Here we got the 1, and then we did what? That's what we're going to do over here. We're going to bring down the next term. Minus 3. And this is an algorithm. It means you do a process. So we're going to just stick with this process. Then we check the next polynomial. That's this one now. We just take the first term divided by the first term again. So you write that off to the side. We go, okay, now we have negative 15x, and we're dividing that by 5x. So first term divided by first term. Just like earlier, we did first term divided by first term. That's the whole process. Does this one simplify? Sure, how much do you get out of that? And you know what? That negative 3 is what we're going to put right here. I'll write in purple for you. Yeah, stick with the color scheme. Negative 3. Would you raise your hand if you saw how we're getting the x and the negative 3 out of that? Okay, we're dividing the first term of these polynomials by the first term of our divisor, what we're dividing by. So our negative 15x divided by 5x, that is what's going up there. That's the whole deal here. What's the next thing?
Multiply the 1 with the negative 3.
Okay, so we're going to take this, and just like we multiplied the x, or distributed the x, we're going to distribute our -3. Let's see what happens. Can you all do this with me? We're going to do -3 times 5x. How much does that give us? Right there, you can check your work. Did we do it right?
Yes.
Yes, we did, because that's the exact same thing. That's what we want. We got to keep going, though. We're also going to do -3 times +1. How much is that? Okay. And remember, we're subtracting these things. So if we're subtracting them, it's really you're subtracting that whole polynomial. Watch what's going to happen so that we can just combine our like terms. This negative will be distributing. If you distribute the negative, that's here and here. This one's going to change to a plus. Parentheses gone. This one's going to change to a plus. Parentheses is gone. And now we just combine like terms. We've changed both those signs. That way it's way easy just to go down, combine like terms. So let's combine like terms. -15x, +15x is -3, +3?
0.
No remainder. It divided evenly. All right. This is one of those ones where we could have factored this, and this would be a factor within that polynomial. That's the idea there. You're going to see that in chapter 7. By a show of hands, how many people feel okay with this division thing? We are going to try one more, but you kind of need to have at least the idea down right now. Are there any questions before we go on?
Where you changed the last, how'd that happen?
Well, remember that we're subtracting this, right? So if I was subtracting -15x minus 3, just like that, I was subtracting that, right? If I'm subtracting that, notice how this is really like a -1, and my negative would distribute. It would change each of those signs, because a -1 times a negative, that's going to be +15x. -1 times a -3, it's going to be +3. That's how we're changing those two signs, okay? We're just kind of doing it within the problem. Good question. Any other questions before we go on? Thank you for that question.
What happens if you get a remainder?
I'm so glad you asked that question. We're going to do another problem. You're a step ahead today. Step ahead. But just one step. Just kidding. Okay, if you set it up correctly, this one could work with synthetic division. Now, I'm not going to show that to you. If you want to see it, come and see me on the side. I'll show you how to do synthetic. We're going to do this one like we did this other one. So what that means is we're going to set this up, and our first polynomial is going to go inside of our division symbol here. And then we start dividing. If you really didn't get this one and you're just raising your hand because everyone else was doing it, follow along with this next example, okay? Because you really do need to understand how we're getting what we're getting. The first thing we do again, we're really not worried about that +2. That +2 is kind of like a trailer. It just follows everything along. What we're really worried about are these terms, our first terms, divided by our first term. Are you with me on that? That's what we care about. So what we do to get the very first term of our quotient, we're going to take the 2x to the 4th. You see where I'm getting that, right? Divided by the x. You see where I'm getting that? And what we get out of that is a 2x to the that is what's going to go up top. Nod your head if you're comfortable getting the 2x to the 3rd out of this one. Good, okay. So I'm going to erase that. That's our first piece of the puzzle. And then, like we did before, we're going to distribute this across our divisor, the very first polynomial that you see out here. So when we distribute this, we're going to get 2x to the 4th. Hey, looks like we've done it right. And then plus 4. X to the 3rd. Is that right so far? a second. That looks wrong. Why does that look wrong?
Just a cube and a square.
Can I subtract the cube from a square like that?
No.
That's a problem. I did this on purpose so you can see this, but what you have in division, you have this thing where you're distributing, and chances are you're going to have every power of x if you do that, unless this one's kind of a special polynomial. But if it's like this, where you have a x, then a number, kind of like this one, x then a number, you're going to have a spot for every, you have to have a spot for every place value. It's kind of like a place value in division. You have to have a spot for every potential power of x. So did you see how in our first polynomial here, we have x to the fourth, but then it jumps down to x squared? You see that? That's going to hurt us because we have no spot for our x cubed. And so what you do in this problem, unless you want to get stuck like we just got stuck, because you are going to get stuck. There's nowhere you can go from here. Unless you want to get stuck, what you do, I'm going to rewrite this, but I'm going to write it after one term. You have to have a place, like kind of like a place value holder for the x cubed. So what we're going to do is we're going to go, oh, okay, I'm going to add in here 0x cubed. It didn't have any x cubed, so I'm having 0x cubed. It's just a spot so I don't forget it so I can subtract from it. You with me on this?
Yes.
Yeah, that's the idea. And then I'm going to finish off the rest of it. Minus 3x squared plus 5x minus 2. So key idea, make sure you have at least a spot for an x cubed. Now, why am I putting 0x cubed instead of like just x cubed?
Because there's none in the original form.
If I put x cubed, it would imply there was one of them, and there's none of them, so I have to put the 0 there. Still okay with that? Okay, now we go ahead and we're going to subtract like we did before. Remembering that we do really have parentheses here, so what's going to happen, everybody in here, what's going to happen to this second sign here?
Negative.
Okay, so I'm distributing this, that means I'm losing the parentheses, this is becoming a negative, and this one is also becoming that minus. So I've distributed my subtraction across the parentheses, that's making them different signs. Okie dokie? Now we just get to combine like terms. So can you do that? 2x to the fourth and negative 2x to the fourth, how much do we get?
0.
We have 0x cubed, we have a negative 4x cubed, that's going to be... You okay with how that sign's a minus? You okay with how that sign's a minus? Be sure. This is a big deal. Don't forget about that one. Remember, when you're subtracting, it is distributing across parentheses. I've said that several times now, but it needs to stick. Okay, our next step, we're going to bring down that negative 3x squared, and we're going to start this process over. I'm going to give you about a minute. I want to see if you can finish off the problem. Okay, you've seen the main step, that one. This one is now the same idea as this. Finish it up. Go ahead and see how many times x goes into negative 4x cubed. Write that up top. Distribute, subtract, continue. I'll be walking around. Let's take about a minute and a half to do this. Oh, Daniel and Jacob, I put C on the roster because I don't have you enrolled yet. Have you added yet? You need to go do that. Did you add?
I'll double check that.
Double check, because it didn't show up yesterday online. Okay. It's after a certain date that I can't add you. That wouldn't be good. Okay, I'm going to do the next step here so you see if we got this thing right. So we're checking how many times x goes into negative 4x cubed. We're just writing the first terms here. Hopefully you did that off the side, or you're good at this, you do this in their head, that's fine. You're going to get negative 4x squared. Did you get negative 4x squared? How many people did get negative 4x squared? Beautiful, all right. That's going to go here. That's gone. When we distribute, we'll get negative 4x cubed. That's exactly what we wanted to get. And then minus 8x squared. Are you still with me? Now keep in mind, here's an important part. You are subtracting across parentheses like that. That's what's happening here. When you subtract across parentheses like that, it changes the second sign. This one, most people get that right. You know it's going to be gone, right? So everyone just goes, oh, it's gone. But the second one's the important one. So notice that you're distributing a negative. If you distribute a negative, you change both signs and remove the parentheses. That's what just happened. Did you do that on your paper? Awesome. Now you combine like terms. This is 0. This becomes not negative 11x squared. If you got negative 11x squared,
5x.
what happened to you is you did not distribute that correctly. You added it incorrectly. Okay, the next part's going to blow up in your face. You go, why is this not working, Mr. Leonard? You told me wrong. No, just watch this again or something. Pay attention. You need to change that second sign and then combine like terms. This is going to be the positive 5x squared. Did you get positive 5x squared? Good. All right. Fantastic. We continue. We're almost done. We're going to have a plus 5x. We'll keep going. If you check how many times x goes into 5x squared, you do it off to the side, wherever you want to do it in your head, you're going to get plus 5x. We're going to distribute. We'll get 5x squared like we were supposed to, and we'll get plus 10x. Are we still right so far? Again, we're distributing this negative across some parentheses, so we're going to drop those parentheses, and our signs are going to change. This is going to be a negative, this one's going to be a negative, and then we combine like terms vertically. So here, this is, our first terms are gone, they make 0. Our second terms are going to be negative 5x. Did you still have negative 5x? And we're going to bring this down.
Yeah.
Almost done. Okay, our last little part here, we're checking negative 5x divided by x. Hopefully you get negative 5 out of that.
Yeah.
Question?
No.
Oh, okay. You have a little conversation there. That's cool. Was it about math?
Yeah.
Yeah.
Even better. It made me so proud one day. It was like math 80 class, and these two people in the back were just it's like, man. And then I walked a little closer, and they were still going at it, and I was thinking, they're having some like argument. They were talking about the weekend. They were arguing about math. I was so proud. I was so proud. Okay, so we go ahead, we distribute this one. We're going to get the negative 5x. We're going to get negative 10. We are subtracting, so again, we're going to change both those signs. I hope you're seeing the pattern here. The signs changed. Ta-da, we're subtracting. It happens. So we're going to put a plus here and a plus there. We're going to combine like terms. 0, positive 8. Did you all end with positive 8, by the way?
Yes.
Good. And we get this remainder. Of course, x does not go into positive 8. So what do you do with the remainder? Well, depending on whether it's positive or negative, you're going to put a plus or a minus at the end of this thing, the end of your quotient. Here we have a positive, so what we're going to do, we're going to put plus 8. And then you divide by your divisor over here. You divide by that thing. So we put the 8, and then we're going to put it right over x plus 2, and then you're done. That's how you deal with the remainder in long division polynomials. Put your remainder over x plus 2, because that's what you're dividing by. So we get all this far, plus or minus, depending on whether it's positive or negative, 8 over x plus 2. How many people feel okay with this long division idea? Cool. We're now done with our review. Yay. We're done with C.4. What we get to do now is start chapter 7.